Hello and welcome on my YouTube channel. I'm Tom Dallas and this right here in my hands is the Armattan Chameleon TI with the Helio RC spring all-in-one flight controller, and I'm going to show you how to build this quad. Stay tuned. I will build my Chameleon TI with the following parts: the Helio RC all-in-one flight controller, 4 T-motor F35A BL Healy 32 ESCs, 4 Brother Hobby Returner R6 2207 2400 kV brushless motors, the TBS Unify high voltage video transmitter, the Foxia Monster Mini Pro FPV camera with a 1.8mm lens, the FSky XM Plus receiver and a Foxia FPV antenna. First I set up the bottom plate of the Chameleon frame with the titanium cage and the rear spacers, as well as the nylon standoffs for the FC. This requires the M3 60mm bolts for the FC mount, the M3 12mm bolts for the titanium cage and the M3 10mm bolts for the aluminum rear spacers. In addition to the rear spacers, I also need the carbon shim plate for binding the titanium cage. For the different bolts there's a suitable 2mm hex screwdriver needed. Now I temporarily mount the Helio RC all-in-one flight controller. I will install the purple soft mounts at the end to avoid damage during soldering. Furthermore, I install a motor with a soft mount. Here I use 8mm screws instead of the 6mm screws that comes with the Brother Hobby Returner. Otherwise the soft mounts won't fit under the motors. When installing the motor, it's important to ensure the correct length of the screws. The screws shouldn't get too close to the windings of the motors. To go on, I will fixate the FC roughly with 2 nylon nuts. After assembling of the FC and the motors, the arrangement of the ESCs can be made. Therefore I try to get the exact same distance between the single ESCs and the motors. If it should come to technical difficulties later, it will be easier to exchange the motors without cutting or extending the motor wires. Therefore I temporarily hold the ESCs with electrical tape in place. Now I try to figure out the ESC cable management and cut the wires to the correct length. The white signal wire and the corresponding black wire will be soldered to the corners of the Helio FC, and the plus and the ground power wires are soldered to the ESC solder pads on the front and rear of the Helio FC. Be careful not to cut off the wires too short, they shouldn't be under tension. I want to install the receiver and the video transmitter in the back of the Chameleon. I also try to plan the required space in the arrangement of the ESCs. When all ESC wires are shortened to the correct length, the ESCs can be prepared for soldering to the Helio FC. To make the individual steps more clear, I remove the ESCs from the arms again. The wire ends are stripped and tinned with solder. Additionally, I remove the titanium cage from the Armattan Chameleon again to get more space to solder. First of all, the affected solder pads on the Helio FC must be tin plated completely. The SIG plus and ground wires will be soldered to the positive and negative ESC solder pads on the Helio FC. The white signal wire will be soldered to the top of the solder pad at the respective corner on the FC. The thin black wire twisted with the signal wire will be soldered from below to the soldering pad at the corner. To solder the wire on the bottom of the corner solder pads, I take the FC from the Chameleon and turn it around. Please make sure to keep the wires twisted. Now I rebuild the titanium cage to the Chameleon and put the FC back into its position with the ESCs. Then I push the shrinking tube that comes with the T-Motor F35A all over the ESCs so that the motor solder pads are exposed. And then we are at the motors. I mount these with the soft mounts and the M3 8mm screws on the four arms of the Chameleon. I only use 2 screws for each motor to hold them in place. I will tighten the motor screws later with Loctite. Now I take the ESCs back on the arms again and hold them in place with electrical tape. Then the motor wires can be cut to the correct length. In order to solder the motor wires to the respective ESCs, the soldering pads on the ESCs need to tin plated. The wire ends of the motors must be stripped and also tinned. And then the motor wires can be soldered to the ESCs. At the end of the rough solder works, I have to solder an XT60 battery wire. Here I use an AWG14 wire. Many 4S batteries already use thicker AWG12 wires. These thick wires are usually difficult to solder to the FC and are also quite inflexible, which also makes the binding and the wire routing more difficult. Theoretically, a thinner wire has a higher resistance and would heat up at high currents. But in this case it's almost not measurable because of the short wire length. In comparison, the ESC wires are AWG18, the motor wires are only AWG20. To protect the XT60 wires against rubbing and straining, I've put a shrinking tube around them and tightened the wires with cable ties. Finally, the cables can be shortened to the right length and soldered to the Helio FC. To protect the electronical parts against voltage peaks, it's essential to solder a capacitor to the battery input. Therefore I have selected a Panasonic low ESR 25 volts 470 microfarad capacitor. Alternatively, there can be soldered a capacitor to each single ESC with a corresponding smaller capacity. If you want to run batteries larger than 4S, there must be a capacitor with a higher dielectric strength selected. Now I take the TBS Unify HV video transmitter in its position. Armattan provides two options for attaching the SMA pigtail. I will introduce you to both options. The first one allows using rubber inserts to attach the supplied plastic tubes for the antennas. The disadvantage of that option is that you can't lead out the XT60 battery wire backwards. In this case, the XT60 wire must be lead out at the front or at the back of the top plate. If you fly with a larger battery and an action cam, the XT60 connector is on the way. Honestly, I don't like the plastic tubes and the rubber grommets. In my opinion, it's just a question of time until it will break. Personally, I prefer the second option with a smaller carbon plate. There the SMA adapter of the pigtail can be screwed on and there's enough space to lead out the XT60 wire out at the back. You also can lead out the antennas on the back or on the top with cable ties. Now I take the preferred carbon part for attaching the VTX pigtail to the rear spacers. I cut out a small corner from the shrinking tube of the Unify HV to make it easier to move the pigtail into the wanted position. To screw the pigtail to the carbon plate I use bolts and nuts from a M2 screw set. Unfortunately, these bolts are not included within the Armattan Chameleon. Now I get the video transmitter in its position and fasten it temporarily with a cable tie. I lead the wires of the Unify under the Helio FC because the soldering pads for current, signal and smart audio are all at the front of the flight controller. The Unify HV will be powered with a battery voltage, so you could also solder the Unify directly to the battery input. Seen from this perspective, the Helio FC delivers battery voltage to the two front camera solder pads on the bottom. Because the Unify has its own LC filtered 5V output, I will power my FPV camera with the Unify HV. In addition to the power supply for the Unify HV, there's also the white FPV camera plug. This provides 5 volts plus and ground for the FPV camera and transmits the video and audio signal. The white audio wire will be soldered to the smart audio input. The 6th solder pad at the front counted from the bottom. This solder pad is bridged to the TX5 input on the Helio FC. The yellow video signal wire from the Unify HV is soldered to the video out. Seen from this perspective, on the 5th solder pad at the front counted from below. In the following, the wires for ground plus video out and smart audio will be cutted to the right length. The wire ends and solder pads on the Helio FC will be tinned before soldering. And now, please solder the yellow wire to the video out, 2 solder pads above the one as shown in the video. Accidentally, I soldered the video out wire to the video in. Unfortunately, I just noticed my mistake at the end of the build. Now we get to the FPV camera, in this case the Fuxia Monster Mini Pro, and this is pretty self-explaining, it's a mini-sized camera. To fit the camera into the Chameleon titanium cage, the Monster Mini must be enlarged with a bracket up to the standard camera size. The camera will be screwed to the titanium cage with the M2 8mm bolts. Once you've untangled the wires that comes with the Fuxia Monster Mini, you will see that the wire can be used to make a direct connection between the camera and the video transmitter. In this case, we connect the camera to the inputs on the Helio FC. I cut the wires to the matching lengths. Please do not cut the wires from the small white plug. Later the camera controller can be plugged into it to set up the Fuxia Monster. Then the wires can be prepared again as usual. The purple wire can be removed from the plug. This wire is used for the voltage display in the camera own OSD. We will show the voltage on the Butterfly OSD, so it's not needed here. The Fuxia Monster Mini can be powered with 5 up to 40 volts input voltage. I will power it with the LC filtered output of the Unify HV. For this, I cut the power output wires from the video transmitter and from the camera to the right length and solder them together. I also need a little piece of shrinking tube. I cover the Helio FC because I am soldering over it. So now the signal wire from the Foxy Monster Mini must be soldered to the video input on the Helio FC. Because I didn't notice my previous mistake until now, I accidentally soldered the video wire on the VTX video output instead of the video in. Of course, the wire must be soldered to the video in, 2 solder pads further down. Finally, I plugged the camera connector into the back of the Foxy Monster Mini Pro. I will leave the camera controller plug behind the camera. Later I will hold the wires in place with a cable tie. In order to find my copter in case of a crash, I will solder the buzzer on the buzzer plus and ground solder pads. Now the FSky XM Plus receiver needs to be soldered to the Helio FC. Following the instruction picture, I solder a yellow wire on the S-bus solder pad and the red and the black one on the 5 volts and the ground pads of the XM Plus. Then I protect the XM Plus in a small piece of shrinking tube. I cut a small corner into the shrinking tube for the bind button. The XM Plus will be soldered to the right solder pads on the top of the Helio FC for S-bus, 5 volts and ground. The first solder pad on the right side is for a S-port input. The FSky XM Plus isn't a telemetry receiver, this solder pad won't be used in this case. If you use a FSky XSR for example, you can solder the S-port wire to this solder pad. After I've thought of how to lay the wires to the XM Plus, I prepare the wires and solder pads again as usual. Finished! The solder works are done. Now I remove the cable tie from the temporary attached Unify HV video transmitter and tape down the Unify and the XM Plus on the bottom plate from the Chameleon with double-sided 3M tape. So now we get back to the purple soft mounts for the Helio FC. These will be pressed into the mounting holes. Personally, I would use a small hex screwdriver for help. Finally, the nylon nuts will be screwed on. The nylon nuts shouldn't be tightened too much so that the FC is able to move in the soft mounts. To complete the works on the titanium cage, I screwed 2 more M2 bolts into the camera splints. The spacer at the front of the cage is fixed with the M3 10mm bolts. The M3 6mm and the M3 4mm screws will be attached to the 2 upper carbon plates. Now the battery plate foam and the HD cam plate foam can be taped onto the upper carbon plates. I am not taping the battery plate foam yet. Instead, I'm thinking of taping a piece of Velcro tape whose counterpart is taped on the bottom of the battery on the top plate. I lead out the antennas on the top sides from the upper carbon plate. To attach the antennas, I use 2 cable ties and shrinking tube. And finally, I can heat up the shrinking tube on the ESCs. Now there are several ways to hold the ESCs in place and to protect them. I taped the ESCs on the arms of the Chameleon with double-sided tape. The double-sided tape also works as a soft mount for the ESCs. Additionally, I wrap electrical tape around the arms with the ESCs. Here you can also put a propeller wing or another piece of plastic over the ESC for protection. A cable tie instead of the electrical tape could also be used as attachment if you don't want to hide the ESCs under the electrical tape. However, with a cable tie the pressure is only on a small place on the ESCs. With the electrical tape the pressure is distributed all over the ESCs. That's why I choose the electrical tape. Now I attach the remaining motor screws. It's recommended to use Loctite so the bolts won't get loose. Now I take a strain relief on the XT60 connector with the help of 3 cable ties. If you plug the battery in and out, and especially on a crash, the forces would directly go to the solder pads on the Helio FC. To counteract this, the XT60 connector is secured with cable ties. Last but not least, the video antenna will be screwed onto the SMA connector of the Unify HV pigtail. Now the Armattan Chameleon TI with the Helio RC all-in-one flight controller is finished. Thank you for your attention, I hope you enjoyed the video. If you have any questions or feedback, write it in the comments below. In my next video I will continue with the Armattan Chameleon TI and the Helio FC. Then I will show you how to flash the Chameleon and how to set it up on Butterfly. Stay tuned. See you on my next video.